Okay, partial fractions. What's the idea of partial fractions? Um, firstly, let me firstly say that we have this integration here of 5x plus 1 divided by um, let me there are two cases, so let's start with okay, let's start with this one. Okay, let's say it is 5x squared plus 1 divided by x plus 1. Okay, dx, of course. Okay, let me say that I have this example here. How would we solve this with our knowledge? We know, we have learned a lot of techniques to perform, but here it's different because we know if we use u substitution, we will get, if you say that x is like x is u, you will get 1, or x squared is u, you will get 2x, so you don't get to rid, you cannot eliminate the other, or basically you cannot find a derivative that gives you something that is in this function here. So the solution here is basically the idea of partial fractions, but actually we have studied this technique a while ago. Actually, it's actually not that much of partial fractions or the idea of it, because if you know how to do long division for polynomial, you will be very, actually it's not polynomial, it's just linear and quadratic. If you can do the long division, you will solve the question. And basically, what's the idea of long division? How do we okay, let me introduce you to the cases. Basically, let's say that okay, let's say that let's say, okay, it is the denominator. 5x squared plus 1 is the denominator, and x plus 1 is the dominator. Okay, so if the degree of the denominator is greater or equal to the degree of the numerator, then you just do long division and you solve it. So if I call f of x, if I say f of x is the denominator, okay, and it has a degree of what? Degree of 2, and g of x is the, let me make it better, g of x, okay, and g of x is what? G of x is the dominator, which has a degree of what? Of 1, okay? So the degree of the denominator is less than the degree of the numerator. So here it is basically long division. That's the idea of this case here. There are two cases, so don't worry. It's not like the u substitution, or no, it's actually not the trigonometric substitution. It's just very straightforward. It just needs your it's just some steps, and that's it. Okay, so here this is just long division. How do you do long division? Well, let's see. Let's try to do it. Okay, I'm just hoping that I can. Okay, I have to, let me draw this line. This line indicates that I have to move to not, just write things and not being shown in the video. So basically it is x plus 1, okay, and you do the long division, which is, here we will get 5x squared plus 1. Okay, so what do you need to multiply x by to get 5x squared? Well, you need 5x. Okay, you will get 5x squared plus 5x. Cool. Now we have run into a problem actually, and you will discover it right now. We will need to subtract for sure. This is the idea of the long division. So if you subtract 5x squared from 5x squared, you will get 0. And 1 minus 5x, it's not the way we do it actually. We do it depending on the degree. The degree of 1 is 0, right? Because it is not actually it doesn't have a variable. Or actually, you can say it does have a variable, but the degree of it is 0. So it is like 1 to the power x to the power of 0. You can say like this, or you can just say it is 1. So yeah. And here I will write 0 x. Okay, to make it organized or in the order with respect, to degrees. Okay, sorry about the noise. So this will be 0. Okay, I hope this is not disrupting you. I don't know what's going on there. Someone's like, I don't know. Come on. Okay, let's continue, guys. So this will be 0x minus 5x, which will be negative 5x, right? And this will be 1 minus 0, or you can just bring the 1 down here, so it will be plus 1. Okay, now, can I multiply x by something to get negative 5x? Yes, I can, which is negative 5. So this will give me negative 5x minus what? Minus 5. Okay? Okay. So if I subtract now, I will get 0. Negative 5x minus 5x will be 0. Okay, because it will be negative 5x plus 5x, which is 0. And 1 minus, which is plus 5, is 6. Cool. Now, I hope you didn't lose the idea of, or the logic here. What we're doing here, or what will the result be here? The result will be, okay, and I hope you know it before I, just tell you what it is. The result is always this, right? 5x minus 5, okay? Plus, we have a remainder here. 6 divided by x plus 1. Okay, now, I hope that you know why, and I will give you this idea. Let's say that we have 15 divided by 2. Okay, let's do a long division. It is 2 and 15. We multiply by 7. We will get 14, and the remainder is 1. What is the result here? The result is 7 plus 1 divided by 2, right? The remainder divided by the divisor. Why? Because 15 divided by 2 is equal to 7.5, right? Simple. 7.5 plus 7.5 is 15, which makes sense, right? So this is just, I don't know, this is just like, I don't know what I call this, like, I call it like hint or logic, I don't know, whatever you call it. Anyways, let's do it like this so we are happy. Okay, let's go back to our work here. So we got that it is 5x minus 5 plus 6 over x plus 1. Okay, cool. We have done the first part here. Now we just go back and integrate, and let's do it. Okay, this work seems like a little bit more organized, or like too much organized for me, because I don't like normally organize my work. So yeah, it's kind of like, okay, yeah, I have to be careful. It's like, okay, no pressure. Okay, so this will be the integration of what? The integration of 5x squared plus 1 divided by x plus 1 dx will become, after long division, this, right? So we just bring it back, right? Which will be 5x minus 5. Okay, the noise has gone. That's good. Hopefully it will just continue like this. Plus 6 divided by x plus 1. Okay, dx. Okay, I'll ask you a question. Why did we use this idea of long division? Okay, the idea here, the problem we run to while, integrating is the power. What we have done here, we have reduced the power, right? Here it became 5x minus 5. Here it became 6 over x plus 1, which we know how to integrate, hopefully. So what's the integration of 5x? It is 5, because 5 is just basically constant, so we can just pull it out, and it will be x squared divided by what? Okay, now the work, as I kept it organized, let's try to, maintain. This will be x squared divided by 2. And I always keep checking by just deriving it very fast in my brain. So, okay, I have to do this line so I don't, just, skip without you seeing what I'm doing. So this will be x squared divided by 2. Okay, okay. If you derive it, you will get 2x and 2 will go with 2, so yeah, this is right. Minus, what is this? This is 5, and what's the derivative, what's the integration of constant? It's x, right? You can say what's the integration of 5, which is 5x, derive it, you will get 5. Okay, now, this is the place where some people get confused or something. This is very simple actually. So plus 6. Pull the 6 because the 6 is a constant, right? And the thing is, we have integration of 1. Let me write it here. Integration of 1 over x plus 1. Okay? What is the dx? What is the integration of 1 over x plus 1? Okay. You may say, okay, let's use substitution. Okay, let's use substitution while you don't need it, but actually, let's do it for the start, and you will get the rhythm. I'll say, if you get the rhythm, you will do it like in seconds. Actually, you will not need the u substitution, but let's use it for starting. So u is equal to what? X plus 1, and du, or small change of x with respect to small change of u with respect to small change of x, this is equal to, what's the derivative of this? Or the slope, if you just give you a flashback or something in what we're doing here. Okay, so this will be what? Hope it's clear. This is y, this is x. Okay, so this will be 1. So du is basically what? It is dx. So you see, there is actually there is no benefit of using the u substitution if you will just get du equals to 2 dx. But let's do it anyways to give you the idea. So this will be the integration of 1 over what? Over u, du. Okay, what's the integration of 1 over u? You will just say it is ln absolute value of u, and I will say that you are right. Okay, and that's the solution basically. But I will prefer to say that it is the integration is ln of u divided by the coefficient of u, which is 1. And you will know why right now. Now this is right, and you will just get it in terms of x, right? So you will get ln of absolute value x plus 1. Okay, let me make it like this. I'm sorry about the noise. I'm sorry. I'm so sorry about that. I don't know why people shout in like midnight. I don't know. Some people try at night. Whatever. So this will be ln of x plus 1. Okay, divided by the coefficient of x, which is 1. In this case, even if you don't divide, you will get it right. But I am saying divide because if it was something like do I have space here or something? Okay, let's change it very fast and then just to give you the idea because it's very important. So let's say it is 1 over 2. Okay, this is 2. Hopefully you can see. No, it's not good. This is ln of, let's say it is 2x plus 1. Okay, so this will be what? 2x plus 1, and the derivative will not be 1, it will be 2. So this will be not dx, it will be 2 dx. So u or du divided by 2 will equal to dx. Got it? So therefore, we will have to divide by 2 here. And then this will be divided by 2. And then this will be divided by 2. So everything will be divided by 2. But in this case, we don't have the 2, so we don't need it. I just wanted to clarify it for you, because in the future, I am sure you will be doing like you will run like into like problems that are like lengthy and like this, and you will not have that time to spend doing u substitution for very simple and rather easy things. So yeah, you will not need that. Just for the start, you just need to get the idea. Okay. I hope I didn't mess things up, and if I did, sorry. This will be 1, doesn't matter, you know. I'm just saying to, you know, make sense of things, because later on we will get like things that are similar to this, so therefore I wanted to clarify it here, so when you get better, you'll get better. Okay, I hope the light is not that bad. I don't know, the shadow of my hands, I think. Anyways, so this will be 5x squared divided by 2 minus 5x plus 6 ln absolute value of x plus 1. Let me make the one plus c. Don't forget your c. To prove that this is right, the ln, just derive it. It will be 1 over x plus 1, right? Which is right. And the derivative of x plus 1 is 1, so, or the coefficient of x is 1, so you don't need to divide by 1 here, but yeah, it's just like this, and that's the solution. Now, this is case 1, guys. Case 2 is different. Case 2 is another story, where we will get into the idea of partial fractions. Yeah, now this is basically the idea of long division, I'll call it, and things like that. And as you see, the work starts to get or not that organized step by step, so I don't know what will happen at the end of the video. Hope it will not be that bad. Okay, so we did this, we found the answer, and this is the answer here. Now just checking. Okay, cool, it's right. Okay, yeah. Did I miss something here? Why wait. Oh yeah, there is something I wanted to tell you also about it. You may see it if you were doing like exams and multiple choice and things like this. You may see it something like this: 5x to the power of 2 divided by 2 minus 5x plus, okay, ln, okay, absolute value of x plus 1 to the power of 6 plus c. Why is it to the power of 6? Because this is a property for logarithmic functions. You can just pull the coefficient and make it to the power of whatever inside the logarithmic function here, which is x plus 1. So it will be x plus 1 to the power of 6. Yeah, that's the idea basically, and I hope you understand this. Let me give you also a hint so you can just understand it. Let's say that you have okay, the cam or the phone, actually, because I'm using my phone, like the camera needs charge. I think I will do parts here. I will do this for part 1, and I will do another part later on, because I need to charge my phone, and then the people here are so noisy, which is awesome for lecturing or for, I don't know, like doing things with maths. Anyways, so yeah, let's explain this idea. Let's say that we have log base 5 to the power, log base 5 of 5 squared. Okay, you all know that the answer of this is what? 2, right? Because it's basically log base 5 of 25, which is saying 5 to the power of what gives you 25, and you will say it is 2, and I will say it's correct. Now, what if it was, okay, log base 5 of 5, and the 2 here, I will not write 2 here, I'll bring it here, okay? So it will be 2 log base 5 of 5, and the answer will still be 2. Okay, oh sorry, I didn't, again I did a mistake. Okay, let me do this line here. Okay, so it will be, let me repeat this part, log base 5 of 5, and I will not write the 2 here, I will write it here, to prove that this is the same as, what? The same as log base 5, okay, of 5 to the power of 2. So you can bring the 2 here or here. And you may be confused because this is not log base e. I didn't write it as log base e. Don't forget that this is always log base e of something inside here. Okay. Okay, and the 6 is here. So the same idea, you can bring it here, you know, and solve. So yeah, I guess that makes sense, hopefully. And I know that you know it, hopefully, just you know, giving some like hint or logic or something like this, just to not like, I know you know the idea, but not to base it on memorizing, but on more understanding, because it's, you know, better to understand things, I guess. So I brought the 2 here and it became 2. The answer is the same. Yay. Okay, thank you for watching. I'm sorry about the noise. I need to continue. This is just the first case here. The second case is more about the idea. This is the simple way of like getting things. Yeah. The next example will be, let me do this. So, okay, and I'll go up. Okay, I have all this space. Awesome. Let me just try to do this. Okay, here I'll do it. So the next example will be the integration of 5 x plus 1 divided by 2x plus 1 times x minus 1 dx. Okay, this is the next example, which will be 5x plus 1 divided by 2x plus 1 times x minus 1 dx. Okay, just checking my work. Okay, now in this example we know that what is the degree? Firstly, what's the degree of the denominator? The degree is 1. What is the degree of the denominator? Okay, I hope you know this idea here. You take the greatest degree, you take the term with the greatest degree here, and you multiply it by the term with the greatest degree here, then you will get the greatest degree for all the denominator. You don't need to multiply, you know. This is a shortcut. So what's the greatest, what's the term with the greatest degree here? Is it 1 or 2x? I hope you said 2x. And what's the greatest term with, what's the term with the greatest degree here? I hope you said x. So you multiply 2x with x, you will get 2x squared. So you know that the degree of the denominator is 2. The degree of the denominator is 1. Which one is greater? The degree of the denominator is greater. So in this case, okay, we don't use long division because it won't help. Come on, Cam, focus. Okay, it will not help here. What we will use is, we will use the idea of partial fractions, and we will say that this is actually equal to the integration of, should I do it right now, or the problem is my phone will turn off because the battery will die. Okay, so okay, I hope I may connect it in the same video. I may just do it in another part. So yeah, yeah. So I don't know. We'll see what will happen.